All right, to start this problem out, I don't know if I really need to go to the whiteboard to do this over here, but I'm going to write down f of x is equal to 5x to the minus 2. And then you could write down, oh, the first derivative. It's relatively simple, by the way. It's going to be minus 10 x to the minus 3. The second derivative is going to be 30 x to the minus 4. The third derivative, and they're getting worse, by the way, there's no doubt about it, minus 120 x to the minus 5. All right? Now, someone says, you know, what are you doing over here? I guess we need to write down a polynomial for this over here, and a Taylor one. And I'm going to say, for the most part, I got a feel for it. And if I'm looking at it, I guess I got to evaluate it at 1, right? So let's write this down then. So, you know, what's f of 1? It's just simply 5. What's f of, f prime of 1? It's just minus 10. What's f double prime of 1? It's going to be 30. What's f triple prime of 1? It's minus 120. Now, before I say anything, I want to point out that most people look at this saying, I don't even know what the pattern is at this point. And part of the reason for that is we kind of multiplied things out. So what I want to do is I want to go back and I want to talk about this again. That it really doesn't pay to multiply this thing out because I'm looking for a pattern over here. So I'm going to write this over here again. F of x. There's going to be a 5 times x to the minus 2. F prime, I'll be very careful with this. I'm going to put minus 5 times 2x to the minus 3. F double prime, what's that going to be? Positive 5, and then I'm going to get 3 times 2. X minus 4. F triple prime, I'm trying to predict in this, by the way, minus 5. Then you get 4 times 3 times 2. So I'm trying to realize that, you know, there's a definite pattern to it. And let me write this over again. I'll write down what I see as a pattern. Definitely 5. And then I'm going to write down 1 factorial x to the minus 2. F prime, I'm going to say minus 5, 2 factorial x to the minus 3. I'm just looking at this to say that, by the way. F double prime, that's going to be 5 times 3 factorial x to the minus 4. F triple prime, that's going to be minus 5 times 4 factorial x to the minus 5. So I definitely see a pattern over here. And I'm going to start writing these down now. And I'll start to erase things too. But I'm not going to multiply. I'm just going to write down the pattern for you. Five, 1 factorial. Minus 5, 2 factorial. 5, 3 factorial. Minus 5, 4 factorial. Super predictable. Super predictable. So what am I going to do now is write down the pattern for f of x now. What's f of x? It's 5 over x squared. Let's write it down. What do you get? First term, 5 times 1 factorial. What's next term? Minus 5 times 2 factorial x. Let's remind ourselves, oh, it's 1. X minus 1 to the first power over 1 factorial. What's next term going to be? Plus, again, we're looking at these guys over here. 5 times 3 factorial x minus 1 squared over 2 factorial. I'm going to write the next one down. I know it's tedious. Plus, no, not plus, is it? It's minus. Very predictable. And you could do this all day long now. Let's see, 4 over 4 factorial. But you know what? I see something now that you may not have seen in the past. Writing it down, you're going to see something now. And you write it down, kind of looking at it, the factorials kind of disappear, don't they? So what's f of x going to be equal to? I'm just going to say, 5 times 1. What's the next one going to be? Minus 5 times 2, x minus 1. What's the next one going to be? 5 times 3, x minus 1 squared. That's easy. All right, let's put the next one down. Minus 5 times 4, x minus 1 cubed. Whoops, I don't need a fraction bar there, sorry. The factorial cancels. 4 factorial over 3 factorial is just 4. What's the next guy going to be? Plus 5 times 5, x minus 1 to the 4th power. And this goes on forever. I'm going to write the sum down now. And f of x is going to be a sum. Well, I definitely see a 5 in every single term. Then what do I see? I see this counting variable. I'm going to say n equals. I'm going to put a 1 down. You know what? I'm going to start with 0. And then I'll go to infinity. And what are you going to get there? N plus 1 times x minus 1 to the n. And this alternates. And I'm going to put minus 1 to the n to get to alternate. Now let me just see if that works out. I'm going to look at the key, but I need to clean it up a little bit. I definitely see the minus 1 to the n power as being alternating between positive and minus. I see that. I see the x minus 1 if n is starting at 0. I do see that. And I see the 5, and then I see n plus 1. Yeah, I think I did okay. Let me write this down for you. And this is going to equal, I'm going to put the 5 on the outside. N equals 0 to infinity, minus 1 to the n plus 1, x minus 1 to the n. All right, let me just see what they asked for. Find the Taylor polynomial. We just did. All right. Now, by the way, this is not true for all x. We could do the ratio test, whatever. But let's just take a look, see how we did. All right. So, 5, the sum, minus 1 to the n plus 1. Yeah, we did okay. We did okay. All right. Again, I know what these things can be difficult. I will say it does proceed as we expected to. We expect it to be somewhat easy. But I know when I say that, I know how difficult it can be to work on problems like this. Everyone gets confused, by the way. Some people take the wrong path. Some people make things a lot more difficult than they really are, by the way. And I'm guilty of that as well. Sometimes I make things way more difficult than they are. Thank you.